We start by extending the 12 edges of the cube across 4 of its vertices that form a tetrahedron. At the tips of these 12 extensions, we grow 12 points, the brown points. We call these points the outer points. Now we construct lines across every single one of the faces 2, like this. 2 times 6 faces equals 12 lines. These 12 lines intersect in some additional points, 6 inner points, the blue points, and 12 middle points, the red points. 6 inner points plus 12 middle points plus 12 outer points equals 30 points in total. The 12 lines split up into 2 sets of 6 lines each, the white set and the brown set. Now we will fade out the white lines. You notice that the brown set partitions the 30 points, that is, every point is contained in exactly one of the brown lines. The white set is also such a partition. The whole configuration of 12 lines and 30 points is isomorphic to a 6 times 6 grid with the diagonal missing, and is called the double 6 or Schläfli configuration. Let us have a look at various symmetric views of the Schläfli configuration. This is the view edge-on with respect to the underlying tetrahedron. This is face-on. From this perspective, it is easy to see that the white partition and the brown partition are mirror images of each other. Now we are ready to construct a generalized quadrangle of order 2, which has 15 points and 15 lines, 3 points on every line and 3 lines through every point. There's a natural one-to-one correspondence between the 12 outer and the 12 middle points. We connect corresponding points by lines to arrive at 12 new lines. Now concentrate on the red line to figure out which middle and outer points correspond to each other. The new lines are 12 of the 15 lines in the generalized quadrangle, and the points they intersect in, 14 of the 15 points of the quadrangle. The remaining point and lines are constructed as follows. We check the main axiom for generalized quadrangles in one instance. Given a point, the red point, and a line not through this point, the green line, there is exactly one line through the red point that intersects the green line. Here it is. The name generalized quadrangle derives from the fact that a circular path in the quadrangle cannot consist of less than 4 lines and 4 points of the quadrangle. That is, a minimal circular path in the generalized quadrangle is a quadrangle. Here are various symmetric views of the generalized quadrangle, edge-on and face-on. Now, this generalized quadrangle also has a nice plane representation. This plane representation is called a doily. The generalized quadrangle of order 4-2 is the union of the Schläfli configuration and the generalized quadrangle of order 2-2. It has 15 plus 12 equals 27 lines, and 15 plus 30 equals 45 points. Here it is in its full glory. Let's go for a little bit of a fly through this wonderful geometry.